So I think we can start right now because I don't think anybody else will be joining.
Okay, ma'am.
Yeah. So like this will be the fifth session of tutorials on fundamentals of electronic materials and devices. And so this week we will be discussing problems from week 5. Like few problems
Okay.
that were part of previous year assignments I've taken, and those questions will be solving. There are only about 12 questions, and I think since you have already revised and went through this part, it might be sort of easy for you.
Yes, ma'am.
Once that is done, we can discuss some doubts regarding the assignment 6.
Okay.
Yeah. Yeah. So is my screen visible?
Yes, ma'am.
Okay, so this will be session 5 of Fundamentals of Electronic Materials and Devices. So without further delay, we can move on to the question. So first question is, the electron mobility in a semiconductor is given as 300 centimeter square P inverse second inverse, and its lifetime is 790 nanoseconds. What is the diffusion length for the electron? And you have to give your answer in microns. Take the temperature to be 300 Kelvin. Choose the nearest value from these given options. So basically you need two equations. Can you tell me what those two equations are first?
One is the diffusion constant we have to calculate, ma'am. For that, I use the equation K to B divided by E.
Okay,
From that, I calculated the diffusion coefficient. Then after that, I calculated the diffusion length using that,
okay.
and it is found out to be 8.4 micrometers.
Yeah, so you have already solved these questions? Like, did you have this question
Yes,
in your
ma'am.
assignment?
Yes, ma'am. Already finished.
Okay, this was from week 5, right?
Yes, ma'am.
So it was part of this assignment, I think. This one. Yeah, this one. Yeah, this
Yes, ma'am.
particular question. Yeah.
Yes, ma'am.
Okay. So your first equation that we have to use is we have to find the diffusion coefficient. For that, you have to use Kb T mu E by E, and from that, once you get dE, you can find out the value of Le. And you got the answer to be, what
Yes,
was the answer? 8.4 micrometers, right?
8.4 micrometer.
Okay.
Yes, ma'am.
Yeah, so I think you don't have any doubts regarding this question, right?
No, ma'am. No, no doubt.
Okay. So next is correct. This is a very direct question. Choose the correct statements regarding the biasing of a PN junction. More than one answer might be correct. Out of these four options, you have to select the right answer based on conditions for a PN junction. So what will be the answer? Like the forward biasing and reverse biasing of a PN junction, if you know, like two
Uh,
options out of that. Yeah.
yes, ma'am. Yes, ma'am. First option is correct, madam.
Okay, then.
Second option is wrong.
Okay.
Third is also wrong.
Okay.
Yeah, D is correct.
Okay. So in these four options, A and D will be
AD.
correct, right? Yeah, so that is correct. So
Yes.
a PN junction is forward biased when P side is connected to positive terminal and N side to the negative terminal, and PN junction will be reverse biased if it's the opposite. That is, N side is connected to the positive terminal and P side is connected to the negative terminal. Yeah,
Yes.
yeah. So the answers will be A and D. So next is, which of the
Yes.
following statements are true with respect to current in a forward biased PN junction? Like now we know that what is forward biasing and reverse biasing. Now out of these four options, which of the following will be true for a forward biased PN junction?
D may be the option, madam. One option. Current is due to lowering of the barrier for the injection.
Okay. Like if you want, you can refer your notes or you can like use other sources, no issues. You just get the answer and tell me. That's all. You can refer any books or anything. It's not an issue.
Yes, ma'am. But sadly, I haven't solved that question actually.
Okay. And like based on your general understanding of a PN junction, how would it be? So current is due to injection of minority carriers or majority carriers or due to drift of thermally
No,
generated
no.
carriers?
Minority carriers ಇಲ್ಲ. Majority carriers, ma'am. In reverse
Okay.
bias, minority carriers.
Yeah. So that option is fine. B is correct. What about the other two
In
options?
forward bias, it is due to majority charge carriers.
Yes. Then thermally drift of thermally generated carriers, will that be a right option in case of forward bias? Basically, in forward bias, it's a diffusion current, right?
Yes, madam.
Yeah. So,
Madam, I
yeah,
have one doubt
yeah,
actually.
tell me.
The fifth unit, problems, fifth big problems. Which of the mechanism causes forward bias in short key junction? They have asked.
Okay. Which of the?
Forward bias current, forward bias current. So that's why I thought answer will be diffusion. This
Okay,
is like
okay,
forward
yeah,
bias, diffusion is current is the prominent current.
yeah, yeah.
But the course result is showing that it's thermionic emission. That answer is wrong.
Like fifth question, right? Which of these is
I
true
don't know
about
why, madam.
diffusion current? So the answer that you gave was
Seventh question, madam.
okay, seventh question. Which mechanism causes forward
A and
bias
D.
current? Okay, in a
Uh,
Schottky barrier. Okay,
yes, ma'am. It is
Schottky barrier meaning that,
diffusion, ma'am.
yeah, no, basically Schottky barrier meaning that it will be between a metal and semiconductor. I think we should maybe think in that direction.
Yes, ma'am.
Yeah, and so the answer you gave was diffusion, right?
Yes, ma'am.
Okay, now let me check the answer sheet once more. I'll stop presenting and check.
Actually, as per I know, ma'am, thermionic emission is during reverse bias. Since reverse bias, the only current that flows is due to thermionic emission.
Okay. Like in the solution
I
sheet,
thought in
it is given that in a Schottky diode, under forward bias, electrons move from the metal to the n-type semiconductor, right?
uh, uh, under forward bias,
Yeah.
the electrons will move from semiconductor to metal, madam.
Okay, it's not the
Short case.
reverse. Okay.
Since the work function of the metal will be less than the work function of the semiconductor,
Semiconductor,
so
yeah,
obviously
yeah.
electrons will flow.
Like that is the normal case, but what happens once it is forward biased?
When it is forward biased, the short this the Fermi level moves above, uh, so that more electrons will flow from
Flow, yeah, the dying
semiconductor
width
to
will
metal.
reduce, yeah.
Yes, madam.
Okay, so you still believe that diffusion is the answer, right? So let me read once more. What mechanism causes forward bias current and Schottky barrier? So forward bias current we have. So basically what happens is that electrons keep diffusing and as a result of that for during forward bias current flows, right?
Yes, ma'am.
Okay. Like in the answer manual, they have given that the idea of thermionic emission will also be used in Schottky junction photodiode, and in that it will be explained, it seems, like in week 8. Like
Uh-huh.
once week 8 and now week 7 lectures were released, right?
Yes, ma'am.
Like it's mentioned in the answer manual that in week 8 you will be learning something known as the Schottky junction photodiode. And in
Madam, that
that,
is unfair, madam, actually.
yeah,
Without teaching, you are asking such questions. How
yeah,
can we
like
answer?
I'll discuss with the faculty. Yeah, I'll ask him like why such an explanation was given. Yeah. Okay, so you still
Okay.
believe that diffusion is the answer, right?
Madam, when I think about forward bias, the only thing that
Yeah,
comes to my
comes to
mind is
mind is
diffusion.
diffusion. Yeah, that's true. Like Zener tunneling, definitely not. Heavy
That is in
document
reverse
definite.
bias, madam.
Yeah, yeah, that's why. Like diffusion is possible, but I'm also not getting the fact why thermionic emission is given. Thermionic emission, there should be like some external stimuli or some like electron hole
Yes,
excitation
madam.
kind
The
of thing or
thermionic
something.
emission is
Yeah.
common in room temperature, na, madam. In
Yes,
room
yes.
temperature, you can experience thermionic emission. Why you need to forward bias it?
Yeah. Okay, so I'll ask the TA who prepared the question, and if there is a mix up, we'll get it clarified.
Okay,
Yeah,
ma'am.
yeah. Thanks for pointing out. Okay.
Thank you, ma'am.
Okay, sure. Yeah. So I think like I'll just note down that question. Question number 7, right?
Yes, ma'am.
Assignment 5.
Yes, ma'am.
Okay. Yeah. So I'll get back to you on that. If I get a response from them, I'll mail you about it.
Okay, thank you, ma'am.
Yeah, sure. So I think now we can continue. So here the answer that what we were discussing was that which of the following statements are true with respect to current in a forward bias. So first one is basically current is due to injection of minor majority carriers, and then current is due to lowering of barrier for the junction. Yeah. So this is not minority, this is majority. There was some mistake, I think. Am I audible?
Yes, ma'am.
Yeah.
Okay, ma'am.
Yeah.
Yes, ma'am. You are audible.
Yeah. Okay. So next is a germanium PN junction diode at temperature is equal to 300 Kelvin has the following parameters like Na is given, Nd is given, Dh and De is given, tau H and tau E is given as 5 μs and A is also given. Calculate the reverse saturation current density. Take Ni to be 2.4 into 10 power 30. Yeah. Can you first tell me the equation that you will be using in this case?
1 second, madam.
Yeah, yeah, sure.
Yeah, I have solved this equation. Like first, we will calculate the diffusion length
Okay.
since diffusion coefficients are given.
Okay. Yeah, like
Then I
can
will
you,
use the reverse saturation current formula, that is Js naught is equal to Ni square E into Dh by Lh into Nd. From that I will calculate the reverse saturation current.
yeah,
From that I found it to be 29 microamps per centimeter square.
yeah, like 29 microamps basically means 2.9 into 10 power minus 5 ampere per centimeter square. Yeah, there it was in
Yes, ma'am.
microamps maybe. Like this one, I just made it in amperes per centimeter square. Yeah.
Okay, ma'am.
Yeah, so this will be the equation you're using. First, you will find LD, LE and LH using root of tau, DE tau E and DH tau H. And once you get that, you can use the equation for JSO.
Yes, ma'am.
Yeah. So next is again a similar question. Again, the temperature is 300 Kelvin and Na and D are given. DH and DE are given. Now we have to determine the diode current density for a forward bias voltage of 0.3. Take Ni to be 2.4 into 10 power 30. I think it was not there in the assignment.
Yes, ma'am. I have to solve it.
Yeah, yeah, you can take your time, no issues. You can solve. Like first, can you tell me what equation
Okay.
you'll be using here? Here they have asked the diode current density.
Like,
A similar equation with an extra term.
the first thing I'm gonna do is calculate the diffusion length.
Yeah. And once that is done, again you have to use a similar
After that,
equation.
I
Yeah.
think I will use the reverse bias, that Js naught I will calculate. Then I will apply it for J.
Okay. Yeah, can you please start solving?
Yes, ma'am. Ma'am, I have one problem with using the calculator that is given provided in the system, ma'am. That is very difficult to use.
Yeah, similar to gate calculator, like everything you have to type in reverse. Yeah. So, but we don't have an options. Have you registered for the
That is
examination?
like 10 power.
Yeah.
Yes, ma'am. I already did.
Okay. So, but in the examination also you have the option only to use this online calculator. So it's better to practice from now itself. Like doing exponents and doing big
But
calculations
the
will
thing
be
is, ma'am,
difficult. Yeah.
like putting powers and all, it's very difficult, madam.
Yeah, yeah. Like in normal calculator, you can everything you can put in one step and you will get. But here, most of the things you will have to write down step by step and then calculate final value.
Yes, ma'am.
Yeah. Otherwise, like if you miss a bracket here, the entire answer goes wrong.
That too also one big problem, ma'am.
Yeah. So, but no options. It is not a
Like
pen and
they
paper
can't
exam,
design it
right?
how we use the casino calculator.
Yeah.
They can't design the Casio calculator, madam. That will be comfortable because everybody uses Casio
Cassia
calculators.
only. But I think for GATE and all the other kinds of examinations, you'll get only similar calculators. Maybe there is something in the algorithm that people cannot change. I'm not familiar with that part, but for GATE examinations also, you'll have similar calculators only.
Then it will be very difficult to clear it, madam.
Yeah.
Madam, I have solved this problem actually. The answer I found as J.
Yeah, tell me. Hello. 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 Hello, am I audible? Yeah, hello.
Madam, screen is not visible, madam.
No, I just stopped the
Now it's
presentation.
visible.
Yeah. Yeah. So, like, what was the answer you got?
Madam, I have calculated for forward current density J.
Okay.
It turned out to be 663.83 ampere meter square.
Okay, but that is not there in the options, right?
Ma'am.
Yeah, like so first basically you have to find LD, LE and LH, right? Once you get that, you have to use this equation for
Yes, ma'am.
J. Like you use the same equation?
Yes, ma'am.
Okay, then where it went wrong?
Like this already I have solved this question.
Okay. Like
Sir,
first,
sir has already. So,
sorry.
sir in the class they have solved this problem, madam.
Okay, so LE and LH you got, right? So DE and TOE you all, and sir got the answer of 3179.6.
No, madam. The answer I got, forward bias current I got is 6.63 microamps. Forward bias current density is 663.83 ampere meters.
Okay, so but when I solved, I got this answer 3179.6.
Madam, can you display the question once again?
Yeah, this one.
Okay.
Yeah, is
Small
there?
thing. Current is 10 raised to minus 4 centimeters per electric.
Okay. Okay, this is 10 power
Minus
minus 2.
for 10 raised to 50.
Yeah. So with that small difference, can you solve?
Ah, yes, ma'am.
Yeah. Yeah, have you noted down the question?
Ah, yes, ma'am.
Yeah, okay. And was the answer solution manual to assignment 5 given to you, or is it yet to be given?
Ma'am?
Like usually they'll publish solutions, right?
Yes, ma'am.
Yeah, in for assignment 5 it was given, right, already?
Ah, yes, ma'am.
Okay.
Ma'am, 316.72.
Yeah, like somewhat, yeah, 317, some small difference is there, but it is somewhat correct only. Yeah. Is the screen visible now? Um, so this was the answer. So in the options, they have 3179.6. Some small difference is there somewhere.
Ah, ma'am. 3.
Yeah. You got
Ah,
316. How much? 316?
3167.
Okay. Like some small, maybe because of substituting some constant or maybe e value or something, there might be a small change.
Okay.
Yeah. But anyway, like the method is correct and somewhat a nearby answer you're getting. So that's fine. Yeah.
Okay.
Yeah. So next is choose the correct statements regarding the breakdown of a PN junction. So four options are there. What is junction breakdown? Refers to sudden exponential increase in forward bias current beyond a particular voltage. So similar four
Ma'am,
options
forward
are there.
delay, reverse bias, na, ma'am.
Yeah, like out of this you have to choose the correct statement.
Okay, ma'am.
Yeah.
Option B, madam. Junction
Yeah.
breakdown refers to a sudden exponential increase in the reverse bias current
Current with
beyond a
particular
particular external
external
voltage.
voltage called the breakdown voltage. Yeah. So, and option B is correct answer.
Breakdown.
Yeah. So next is choose the correct statements with respect to reverse saturation current of a PN junction.
Madam,
Yeah.
actually I am finding that option C might be correct since current is independent of reverse bias voltage.
Yeah.
That is true. Actually, current remains constant
Yeah.
in the reverse bias
Reverse
voltage, and
bias.
until
Yeah.
it reaches a breakdown point, it will go up.
Yeah. So answer is DC and D. Current
See,
is generated by drift
huh.
of the thermally generated carriers in the depletion region. So C
Yes,
is
ma'am.
correct.
In reverse bias, thermal.
Reverse bias. Thermally generated carriers will be there. Yeah.
Yes, ma'am.
Okay. So next again, yeah. So like this is an explanation. The current in reverse bias PN junction is generated by drift of thermally generated carriers, right? Electrons and holes dynamically generated in this region get accelerated towards the N and P respectively due to the voltage, and this leads to a small reverse saturation current called drift current, and it is given by the sim equation that we usually use.
Yes, ma'am.
Yeah, and reverse saturation current is independent of the reverse bias voltage. Next is
Yes,
regarding
ma'am.
avalanche breakdown and Zener. So, like a fill in the blanks, dash breakdown occurs in moderately and lightly doped PN junction with a dash depletion region via dash process.
Actually, for
Yeah,
moderately doped thing, we have avalanche breakdown.
breakdown. Yeah, so what will be the depletion width, wide or narrow? So you have three options.
Wide,
Yeah,
ma'am. In avalanche breakdown, depletion width is wide.
wide. Yeah, and the process will be
Process will be impact ionization.
ionization. Yeah. So, like now, can you tell me what do you understand by Zener breakdown or yeah, like difference
Zener
between
breakdown
Zener and
occurs
avalanche?
when you have a higher doping. It
Yeah,
occurs due to tunneling
tunneling. Yeah, and the depletion
and
region in that
narrow.
case will be narrow.
Narrow.
Yeah, that's also correct. So basically, answer is A, avalanche breakdown, wide depletion region, and processes impact ionization. Yeah.
Yes, ma'am.
So again, a similar question based on Zener breakdown. Here, like we have to choose the correct statement is that avalanche occurs at high doping, Zener occurs due to ionization, avalanche occurs due to tunneling, Zener occurs at high doping concentration. So which will be the correct
Option D. Zener occurs at high doping
doping
concentration.
concentrations? Yeah. So next is during the growth of a heterojunction semiconductor, it is observed that the growth occurs layer by layer and there is no formation of ions. So which growth pattern is likely to be followed?
Layer by layer. The sir told in online class about this.
Yeah,
Uh, prank 1D growth mode.
yeah. So basically, like in Volmer Weber, what happens is that whenever we are depositing layers, island type formations will happen, right? And in
Yes,
Frank
ma'am.
van der Merwe, what happens, whatever we deposit, one layer will be deposited along the other. But when these two
Yes,
are combined, that is layer plus island kind is observed in Stransky.
yes, ma'am.
Yeah. So answer will be Frank van der Merwe growth mode.
Yes, ma'am.
Yeah. So now next is a very direct question. Choose the correct statements regarding a PN junction. So conducts mainly in forward bias, act as a rectifier, conducts mainly in reverse bias. Forward bias current is of the orders of magnitude higher than the reverse bias current. So which of these options will be correct regarding a PN junction?
I, I will go with B and D, ma'am.
Okay. So answer will be A, B, and D.
Okay.
Yeah, since it acts as a rectifier, we can somewhat say that A is also correct, right? Partially.
Ma'am, partially,
Yeah, like
like it is
see,
wrong.
answer like marking systems will also be like that. All of these will carry partial marks.
Uh,
Yeah, like if you miss one option, some point values of marks will be deducted, I think.
uh,
Yeah.
yes, ma'am. Ma'am, mainly okay, mainly term like that also reverse bias is also there, but forward bias dominates. Okay,
Yeah,
the
but
option D,
conduction is in forward bias, right?
yes, ma'am.
Yeah, majority conduction takes place when it is in forward bias. So that's why that option will be
Yes, ma'am.
correct.
Okay,
Yeah.
okay.
So yeah, like today's final question will be like one similar ones you've already solved in your like non-graded assignment, I think. A PN junction has a built-in potential of 0.6 volt and a depletion width of 3 microns at equilibrium. What will be the depletion width when a forward bias voltage of 0.3 volt is applied?
I'm sorry, this ma'am. It is 2.1 micrometers.
Yeah. So can you tell me the equation once?
First, I use the equation for ma'am. In case of forward bias, I have W is equal to W naught square root of V naught minus V external divided by V naught.
Yeah,
Straight away, it comes answer.
2.1. Yeah, now that this
Yes.
whatever is there in week 5, it is clear to you, right?
Yes, ma'am.
Yeah, so now you can tell me your doubts with assignment 6, so we can try solving that.
Okay. Like the problem is that, ma'am, I didn't understand the problems that I've solved during this week 6. I didn't understand the problems.
Okay, yeah, we can. Like, when is the submission? Last date for submission?
8, ma'am, tomorrow.
Tomorrow. Okay, so yeah, like some pointers at least I'll be able to give, I think. So, can you tell me what was the first question that you had about? Six, right?
Sixth one.
Okay, so consider an N-type MOS with donor concentration equal to so and so and intrinsic carrier concentration of 10 power 10. The surface is biased such that there is a strong inversion. What is the electron concentration at the surface? So basically ND is given to us, Ni is given to
Yes,
us, and what happens at strong inversion? There is a relation at strong inversion, right?
ma'am.
Like what, like in that diagram, whenever we are talking about strong inversion, what will be the relation between phi s and phi b?
Phi s is equal to 2 times phi b.
Yeah, that you know, right? Now you have to
Yes,
find
ma'am.
out an equation where you have to finally find out ns, right?
Yes, ma'am.
Yeah,
Ns is equal to Ni exponential phi s minus phi b by kt.
like do we need ps is equal to ni exponential phi s minus phi b by kt, right?
Yes, ma'am.
And phi b also you can calculate. Phi b equation, you know, phi b will be,
Uh, Phi b in EFN minus EFI is equal to 0.393. That is equal to phi b.
yeah.
EFN minus EFI.
So now you can calculate PS, right? We know Ni, we have phi s and phi b relation we have. And now you can calculate PS. And once you get PS, Ns you can calculate from Ni square by PS, right?
Oh, yeah, ma'am.
Yeah. Is it like, is the doubt cleared now?
Yeah, yes, ma'am. But we have a direct formula for Ns. Ns is equal to Ni exponential phi s minus phi b by kt.
Phi s minus phi b, N PS, sorry, can you repeat the equation once more?
Ns is equal to Ni exponential phi s minus phi b by kt.
That is PS, right?
Okay.
That is
No, ma'am.
PS.
That is Ns actually. Ps they have given Ni square by Ns.
Okay. Yeah, PS is
In the
that
class,
that relation is okay. NSPS is equal to Ni square. We can use interchangeably, no issues. But I remember that
yes, ma'am.
PS was equal to Ni exponential phi s minus phi b by kt. Like when you use directly,
Okay.
are you getting the answer like that?
Now I am getting the answer 5.17 into 10 raised to 16, madam. That is not there.
Not there, yeah. So yeah, like like just go through the lectures to come. Like sometimes in the lectures also there might be a mix up in the like exponents they write or the notations they write. So just check in other literature also. Equation for Ni exponential phi s minus phi b by kt is Ps or Ns. Just check that part.
Okay, ma'am.
Yeah.
This time I don't know, ma'am. I am not able to solve even one problem also.
Yeah, like once it goes on towards devices, it becomes more and more difficult. Like since you're from physics background, you're at least understanding what is given in the questions. If you're from a non-physics background or non-electronics background, means like not even this much you will be able to approach questions, I think.
Yes, ma'am.
Yeah. So next your next doubt was
My next doubt was on similarly the problem, 11th problem.
11th problem. Consider most structure using n-type silicon. Nd is given. What is the voltage required to make the surface intrinsic? Give your answer in volt, take Ni and temperature to be 300 Kelvin. So basically, finally, what we have to find out?
I think we have to calculate by yes, ma'am.
Phi S, are you sure it is phi S or phi B?
Uh,
Like we have to
uh,
convert it back to intrinsic, right? I can give you a clue that it is phi B and why it is phi B, you'll have to find out from your notes. I am not supposed to say. Yeah, like see, basically what is that? What is the voltage required to make the surface intrinsic? Surface intrinsic means that we are removing the barrier, right?
yes, ma'am.
Yeah. So it's not phi S, you'll have to calculate phi B in that case.
I think I got answer 0.41 electron volts, ma'am. I'm not sure it is right or wrong.
0 point?
41 electron volts.
Yeah, that's correct. The answer is correct.
Uh,
Yeah. So then,
I use the formula Is is equal to 2 phi b, and that from that I calculated, I think phi b I have calculated now.
okay, yeah, if you have calculated phi B means it's well and good. Or you can directly use the other equation, right? KTL and ND by Ni for phi B.
80 by n. Yes, ma'am.
Yeah, that also you can use.
Okay.
Yeah. Then next question that you have doubt.
13, ma'am.
13. So 13 is consider most structure using n-type silicon. What is the voltage required to create strong inversion? So again, the condition for strong inversion, phi s is equal to 2 times phi
Yes.
b. You have to find out.
Okay, ma'am. I will find out that after
Yeah. And once that is only that is asked, right? Basically, you have to find phi s only. Voltage required to
I
create strong inversion.
then for calculating of phi b, they have given nd for me. Okay, they have given ni. Okay, I can
Yeah.
calculate phi b with that.
Yeah.
Okay, ma'am. I will try to solve this problem.
Yeah. You can solve now and let me know.
Okay, ma'am.
Yeah.
Madam, I'm getting the answer which is not given in the choice.
Like why so? Um, First you can
1.63 electron volts I'm getting.
13, right? Like so
Huh?
basically first ND is given, Ni is given, phi s is equal to 2 times phi b,
Yes,
and you
ma'am.
calculate,
For 5 I calculate K ln ND by Ni.
okay, and 2 times of that will give you phi s. So 2 into 1.38 into
Yes, ma'am.
10
I
power minus
calculated first.
23 into 300 ln 7 power 22 by 10 power 16. Like what were the units that you are
Huh?
calculating in joules or in electron volt?
In electron volts, ma'am.
Okay. Phi, you are finding out phi s, right?
Yes, ma'am.
Yeah, it's supposed to come 0.82. Like, can you read out your, like, how you, like, the equation part? What?
First, ma'am,
Yeah. Hello?
I have written pi s equal to 2 pi b.
Yeah.
For the 2 into pi b is equal to KT ln ND by Ni.
Yeah. And the substitutions, can you tell?
I
2,
solved that.
2 into 1.38 into 10 power minus 23 into 300
Ma'am,
ln.
first I will do the LAN one. Ma'am.
Okay,
LAN.
okay.
First I will do ND.
Yeah,
ND is 7 into exponential power 16 divided by Ni is exponential power 10.
yeah.
So LAN of that answer I got is 15.76. So for that I will multiply 2 into 300
Hello?
1.38 into exponential power minus 23. Ah, yes, ma'am.
Okay. So you're getting the answer as
I
final.
got 1.30 into 10 raised to minus 19
Yeah, in joules, right?
in joules, madam.
Yeah, in the joules, you if you convert that to electron volt,
Divided by 1.6 into exponential power minus 19.
yeah,
0.815.
yeah, then it is there. No, 0.82 is there, right?
But they are asking in millivolt, madam. Millivolt.
No, you're supposed to give in volts. Yeah, like it was in the answer is supposed to be in volts because if you ask in millivolt, all the options will be wrong, right?
Yes, ma'am. It should be in electron volts. Give your answer in electron
Electron
volts,
volts, yeah,
not millivolts.
yeah. So like the
Yes, ma'am.
0.815 you got, right?
Okay, yes, ma'am.
Hello?
Yes, ma'am. Yes, ma'am.
Yeah. So 0.82 will be sufficient. So that maybe it's some kind of a typing mistake or something. It should be in electron volt only.
Okay, ma'am.
Yeah. So next is 14, right?
Okay, ma'am. 14, I don't have any idea, madam. If you
And
ask
what
any question, I can't answer.
and what about 15?
15 also no idea, madam.
Okay, so 14 we'll see. In an N-type gallium arsenide MOS at 300 Kelvin, donor concentration is given, intrinsic carrier concentration. Calculate electron and hole concentration at surface during strong inversion. Again, strong inversion means that up to that condition part we can do 5B, 5S part, right?
Yes, ma'am.
Then after that, again you have to go for finding PS and NS.
Okay, ma'am. PS I will find using the formula that I have KT into ln Na by ND, Na by ND, sorry, Na by Ni.
Uh, first,
And
first you will find out 5B, 5B using KTLN ND by Ni. That part is over. Now once you know 5S, 5B, you can use PS is equal to Ni exponential 5S minus 5B by KT, right?
yes, ma'am.
Yeah, and once you have that, you can use,
Yes, ma'am. I can use that.
yeah, PS 5S is equal to Ni square. PSN is equal to Ni square.
Yes,
That,
ma'am.
yeah, that part you can do.
Okay, ma'am. I will try to solve that.
Yeah, you can. So you can try now.
Okay, ma'am.
Yeah.
Okay, ma'am. Madam, I got PS as 2.35 into 10 raised to 16 and NS as 1.7 into 10 raised to minus 4.
Yeah, 1.7, you can round it approximately to 2, right?
Okay, ma'am.
Yeah. Yeah, one is 2
Okay,
into
ma'am.
10 power
Got
16
it.
and next will be 2 into 10 power minus 4, I think.
2 into 10 power minus 4.
Yeah. So
Yes.
final question is, consider p-type silicon based MOSFET at 300 Kelvin with an acceptor concentration of 2 into 10 power 16 centimeter per minus 3. The intrinsic area concentration is given, dielectric constant is given, and what is the total depletion width at strong inversion? And we have to answer in
Uh,
nanometers. Okay, so first basically equation for width you might remember from week 4, I think. You remember width of depletion region, equation for that epsilon KTln Na by Ni by E square Na, the whole root. There was one equation, right?
yes, ma'am. There was one equation, but I can't revise
Yeah,
it. Forgotten.
you can check. There is actually a direct equation, width of the depletion region at strong inversion.
I got, ma'am. W naught is equal to square root of 2 epsilon naught Na plus Nd into V naught divided by E Na Nd.
Yeah, like that.
Okay, ma'am.
Yeah,
Ma'am, I got acceptor concentration. I have. What about donor concentration?
donor concentration won't be required, right?
Why, ma'am?
Like we can use the equation epsilon 0 epsilon r KT ln Na by Ni by E square Na, right? Because total
No, no, I'm
depletion
not
width is,
getting, madam.
yeah, total depletion width is being asked, right?
Oh, yes, ma'am.
Yeah. So then that particular older equation, if you compare and from that you can find out the total equation.
I'm not getting, madam.
Yeah, like let me see the older equation. Old equation was W0 is equal to 2 times epsilon Na plus Nd V0 by E into NaNd, right?
Yes, ma'am.
This was for the normal case. But here it is given
Yes,
that it is strong inversion. So what happens during strong
yes, ma'am.
inversion according to the diagram?
According to the diagram, in P-type region, we will see a N region.
Yeah. So then would Na plus Nd be required? That is the question I'm asking. Like since it is an assignment question,
Strong.
yeah, I
No,
cannot give you
one.
answer directly. Only thing is that you can use a direct equation. Like, and in that case, Nd won't be required. Only you need Na and Ni. So you have to find out an
Okay.
equation where W is dependent only upon Na.
Not on the voltage also, madam. Applied
Yes,
voltage.
yes.
Not on the applied voltage also.
Yeah, instead of
I was
applied voltage, you are substituting one another thing. Like 5B, we know, right?
we have to calculate 5s now, madam. From
Yeah,
5s, we can solve it. Like WD is equal to 5s to epsilon naught epsilon r divided by E into Na.
yes.
Oh, can I use that formula,
Yeah,
madam?
you can
Since,
use that.
yeah, I will try, madam.
Yeah, yeah, you can.
Madam, I'm not getting the answer they have given in the option. Actually, I'm getting some different answers.
Okay, so basically, like, one, can you tell me the equation that you used?
Ma'am, first I calculated 5s by using the equation 2 times 5e, that is 2 kT ln Na by Ni.
Okay.
I found out the answer to be 1.2 into 10 raised to minus
So
19.
basically, you should like the thing is that you should not be calculating based on phi s. You should be calculating based on phi b. Like we don't need to take 2 times kt ln na by nd by ni. It's just that using phi b itself you can calculate, and then what happens? It becomes epsilon 0 epsilon r kt ln na by na, right? If you take 2 times of
Yes,
that
ma'am.
value, you will get the total depletion bit.
Madam, one question. They have said here strong inversion.
Yeah.
Strong inversion means we have to take 5s.
Is it actually like in this particular case, if you take phi s, like would it be right? That is the question. In strong inversion is just to get the condition, right?
Ma'am.
Like yeah, you know, basically you just tell me difference between phi s and phi b based on your understanding. Then I'll think I'll be able to explain. Like what is phi s and
One
what is
second.
phi b?
1 second. Madam.
Yeah, sure, sure.
Ma'am, 5B is the bulk potential. That is, it is the difference between the Fermi level of the intrinsic semiconductor to the Fermi level of a N-type or a P-type semiconductor.
Yeah,
It is bulk potential 5B.
yeah. And phi s?
But the surface potential 5S is like the difference between them towards the junction, towards the oxide side surface.
Okay. So in this case, what you will be using? They have asked the width of the depletion region, right?
Yes, ma'am.
Yeah.
In the depletion region, we have surface. Yes, ma'am. We don't need actually
Yeah,
here
phi s
5S.
we don't need. Only phi b we require, right?
Yes, ma'am.
Yeah. So based on the diagram, now you are able to understand?
Yes, ma'am.
Yeah. So once you,
Like 5S, we don't need because depletion width is here. So
yes,
for that 5B is enough, I think so.
yes. Yeah. So then in that
If they
case,
asked us to calculate the bending or something like that,
yeah,
we
then
have to take
only we need
5S.
to go to phi s. Otherwise, phi b would be enough. This is just to like
Yes, ma'am.
strong inversion they are mentioning here just so that it clicks in our mind. Okay, instead of using V0, we have to use KTL and Na by Ni. That's all.
Yes, ma'am.
Yeah,
Ma'am, let me try to solve the problem, ma'am, with
yeah, yeah,
that knowledge.
yeah. And denominator, what is this? Epsilon 0, epsilon r. Can you tell me the equation inside the root?
Root of pi s to epsilon naught epsilon r divided by E into Na.
Okay.
Madam, still I'm not getting the answer. I don't know why I'm
Like
not getting.
what answer are you getting? Like somewhere near or very
No, madam, it is like I'm getting like 0 point so many zeros, 4062 something I'm getting nanometers.
okay, like that much small you're getting. Like
Ah,
twice,
yes,
yeah,
ma'am.
twice of this value you have to take. It's actually 2 root of, right? 2 root of epsilon 0 epsilon r kt ln na by ni.
Oh, madam, but uh,
Then
but I have the formula that I have taken to solve. Like sir has solved this problem. Actually, he has taken 5s is equal to E into Na WD, like WD square is equal to 5s 2 epsilon naught epsilon r divided by ENA whole root.
sorry, can you repeat that once more?
WD is equal to square root of
Huh.
5s 2 epsilon naught epsilon r divided by E into Na.
Okay. That is 5s, right? If you are like replacing that with 2 times 5b, then what it will become? Inside the root, 4 will come and that 4 you can take outside and it becomes 2, right?
I know I'm a dumb.
Sorry?
Simple thing, madam. I just missed it.
Yeah,
Ayyo, devare. Yeah, madam. I will once again try.
yeah. And new denominator, was it e square na or e into na?
Ma'am, just E into Na.
Okay. And one more thing you have to note here is that I think whatever you are getting phi value will be in joules, right?
Yes, ma'am. I have to convert it into electron volts.
Yes, and then only you will get final WM.
Okay, ma'am.
Yeah. So one more E will basically come in the denominator, right?
Yes, ma'am.
Yeah, so it will be basically E square Na.
Ma'am.
Yeah. So now your final equation would be Wm is equal to 2 into root of epsilon 0 epsilon r kt ln Na by Ni E square by Na whole root.
Madam, I did get what, ma'am?
Yeah, like final equation now after converting all this, final equation would be Wm is equal to 2 into root of epsilon 0 epsilon r kt ln Na by Ni the whole divided by E square Na.
Ma'am.
Yeah. So now I think you will get the answer.
Hope so, ma'am. Because I'm struggling a lot.
Yeah, like we have like finally you have reached at the point where you wanted, right? Like y phi s and phi b and y e square, all those things. Those conversions and all are actually hidden in that.
Yes, ma'am. I have the soft copy, hard copy in my home. In my home. Madam, I got 222.
Yeah. So it's there in the options. 220 is there, right?
Yes, ma'am.
Yeah. So that's correct.
Okay.
Yeah.
Thank you, ma'am.
Yeah, sure. No problem.
Without your help, I was sure that I won't solve any problem.
Yeah, no issues at all. That's why we are keeping these live sessions. Actually, people are not making use of them. People who have doubt with such assignments, if they come up, they can score marks, right? They can clear their marks. But usually, very few people will
Yes, ma'am.
attend.
Yes,
Yeah,
ma'am. Sure, sure.
yeah. So thank you so
Madam,
much.
what about the formulas, madam?
Formulas,
Formulas?
I think in the examination formula sheet will be provided. At least for
They
basic
will provide,
equations.
ma'am.
Yeah, see now that initially we had our equation for based on phi s, right? But that conversion to phi b
Yes,
you
ma'am.
had to do by yourself.
Okay, ma'am.
Yeah, so basic part at least they will give.
Okay, ma'am.
Yeah. So I think that's all
Okay,
about it
thank
for
you, ma'am.
today. Yeah, you can leave it. So thank you so much for joining. Thank you.
Thank you so much.
Yeah, bye. You can leave now. Yeah,
Okay.
yeah.